like factoring, I guess.
Okay, good.
Factoring.
Let's do factoring. I can make up the problems if it's factoring we're talking about.
Okay.
Typically, I much prefer if the student brings the problems to the session.
Okay.
Because I can make up factoring problems, but it might not be the same degree of difficulty that you're doing in school right now. So
Right.
it really makes a lot more sense for you to bring the problems to the session and then just read them. But with factoring, I've worked with factoring enough that I know where to begin. Okay?
Okay.
So let's just take some simple factoring problems and see how you are.
You have old ones?
If I said factor that expression, can you do it?
Yeah.
What is it? First of all, what method have they taught you? Have they taught you California method, diamond method, or just seat of the pants method?
It's like where you just take like -7 and then write down all the numbers that go into it.
Okay. First of all, let's talk about quadratics.
Okay.
There are very easy problems to factor, and there are harder problems to factor. This is in the easy category. The reason is because the coefficient of the x squared term is 1.
Okay.
If it was a 2, it would be a much harder problem, or a 3, or a 4, or a 5. But if it's 1, you don't really need any of those fancy factoring methods.
Okay.
Here's the way I would do this problem. Let me give you my method and see if you don't like it better than anything you've learned.
Okay.
First step is you're going to split up the x squareds. There's only one way to split them up. After I've split them up, I multiply them back together again just to make sure that that is my first term. It is, okay? Second step is you figure out both signs, not just one, but both. What do these signs, the next thing I have to write, have to be? Is it going to be plus minus, minus plus, plus plus, or minus minus?
Plus minus.
If it were plus minus, that would have to be a negative number. Remember where that plus 10 comes from. It comes from multiplying the last number by the last number.
Right.
In other words, let's take this problem over here. X minus 2 times x plus 3. Well, the first thing I do is multiply that by that. That gives me my x squared. Then I multiply the inside and the outside, which gives me minus 2x plus 3x, which is plus x. But then the last number is minus 6. Whoops, I didn't leave enough room. Okay? But what we're doing with factoring is everything in reverse. So when I look at this quadratic over here on the right, and notice that I have a minus 6, it means my signs have to be opposite. That's the only way you can get a negative number, is with opposite signs. And if I notice that this is a plus 6, that means my signs have to be the same. They don't have to be both plus, but they either have to be both plus or both minus.
Okay.
So in this case, I'm looking at a plus 10. So I know that my signs have to be the same. Now, what are they? Minus, minus, or plus, plus?
Minus?
Because of this one right there. In other words,
Yeah.
if I know that they're both the same, I look to the middle term. The middle term is negative, therefore it's minus, minus.
Mm-hmm.
And now, the third step is really easy. It's factors of that number, 10, that add, because that's a plus sign, to the number 7. Well, what factors of 10 add to 7?
5 and 2.
Yeah. And it doesn't matter where they go. I can put the 2 and 5 like that, or I can put 5 and 2. So this is what I call a first order level of difficulty. These are really easy. There's really only 3 steps. You don't have to fool with that California method or diamond method or whatever they want to call it. Now, we make it just slightly harder. Only reason this is 1 step harder is because it's a minus 10, not a plus 10.
Yeah.
First step
is the x's.
Split the x's up. Second step, both signs. Not one sign, both signs. Always work out both signs at once.
Is it plus?
One's got to be plus, one's got to be minus.
Okay.
Notice that I would not be able to produce a minus 10 if they were both the same. If they were both plus or if they were both minus, that would be a plus something. So this is a key step when you're factoring, is immediately look at that. That tells you what your signs are going to be in general. If it's a negative, it does. If it's a positive, then it tells you they're either both the same, and then you look for the middle term. Okay, now the third step is pretty much like the first problem. I'm still looking for factors of 10, but instead of adding to this middle coefficient, you may need to subtract to that middle coefficient. Well, that's still 5 and 2, right?
Yeah.
Okay, but now it matters where I put the 5 and where I put the 2. So
yeah,
there's a fourth step. And the fourth step is you take the larger of the factors, the 5, and you put it with the sign of the middle term, negative. So the 5 goes right there. The 2 goes right there.
Okay.
Okay? So again, this is a first level factoring problem. It was just 4 steps instead of 3. The fourth step in other words, when these signs are different, you have to decide which number goes with which sign. So there's that additional step. Okay?
Okay.
Make it just slightly harder. Now notice that this is harder because I don't have a 1 in front of the x squared, which means if I were to try to factor it normally, I'd have to break the x's up this way.
Okay.
And that increases the level of difficulty significantly. So if we can do something to avoid that, we always want to do it. What's the very first thing you should look for when you're looking to factor? Here, I'll write it over here. What does that mean?
Greatest common factor.
Okay. Is there a greatest common factor here?
The 2.
Aha. And that's going to change everything. Because what's left?
The x's.
Well, first, tell me after I factor out a 2, what do you have left?
An x.
Divide everything you see by 2. That's what you have left. When you're factoring out a 2, that's what you're doing, is you're dividing every term by 2. So when I divide the first term by 2, I get x squared minus 7x plus 10. So this line is the same as this line. The only advantage is that we've now turned the quadratic part of it into a level 1. Remember what this factored as?
Oh, 5 and 2.
So it looked like a level 2 quadratic, and it would have been had we tried to do it in normal factoring mode. But the fact that we were able to take a 2 out turned the remaining quadratic into a level 1. And we already knew how to factor it, but we certainly can factor those easier than when there's a coefficient in front. Okay?
Okay.
All right. The other really important, there's kind of a priority level of factoring. That's the first one you look for. That's the second. You know what that stands for?
No.
Difference of what?
I don't know.
Perfect squares. Difference of perfect squares. Here is the difference of perfect squares. That always factors into a minus b times a plus b. Okay? An example would be x squared minus 25. You can factor that. It doesn't look like a normal quadratic because it doesn't have an x term. That actually makes it easier. Okay, how would that factor?
X minus 5 and then x plus 5.
Yeah. So this is the second easiest thing to look for. And it also might come disguised. It might come like this. Now, when you look at the bottom thing, you'll notice that that is not the difference of perfect squares. 50 is not a perfect square, nor is 2x squared. But after I factor out a 2, what have I got? X squared minus 25. Now that's the difference of perfect squares. So now it's 2 times x minus 5 times x plus 5. Okay? So always keep in mind this greatest common factor, because the greatest common factor usually will simplify the problem. Now, if I had 2x squared minus 48, well, I can't do that by difference of perfect squares. It has to actually be the difference of perfect squares. 25 is a perfect square number, so is x squared. Okay? Let me just give you a couple of those just for practice. Yeah, let's go back and give you one more also.
Okay.
How would you factor that? Start from the top. Is there any greatest common factor?
No.
Actually, there is. X.
Okay.
Notice that everything can be divided by x. I can divide that by x, and when by divided by, I mean evenly.
Right.
So after you factor out the x, what are you left with? X squared minus 7x plus 10. Again, a simple quadratic. Particularly when they give you cubics, because cubics are not easy to factor. So probably for the next 6 months, when they give you a cubic, you'll be able to factor out an x, because that's the only way they've taught you how to factor at this point. So the moment you see that x cubed, you probably know that there's going to be an x in every term, and you're going to be able to factor out an x, leaving a quadratic behind.
Okay.
And again, we know how to factor that. That's x minus 5 times x minus 2. Okay?
Okay.
All right, so we have greatest common factor, we have difference of perfect squares, and the next thing is just normal factoring, which is where we started out. In other words, when you have a quadratic that has an x squared, has an x, and has a number, that's what I call normal factoring. Let me give you a couple more here. First order, because it's got a 1 in front of the x squared. So we know it's not going to be terribly difficult. Let's just do it step by step. What's the first step?
Split up the x's.
Second step?
It's minus and plus.
And notice that it doesn't matter whether I put minus plus or plus minus. Not at this level. It does if the coefficients are not the same in front of x. But as long as it's x and x, plus minus is the same as minus plus. What's the third step?
Just factor it.
Verbalize it entirely. If you verbalize it, you'll learn it. Factors of 12.
Or 6 and 2.
That do what? So we got factors of 12 that do something. And that's based entirely on what that is. If that's a negative sign, then they're going to subtract. If that's a positive sign, then they're going to add. So in this case, that subtract to what?
Oh.
What's the coefficient of the middle term?
A negative?
1. Just 1. You don't need to even consider its sign. Okay? It's actually easier to not consider the sign. The coefficient is 1. So what factors of 12 subtract to 1?
4 and 3.
Okay. Now, the fourth step, I got to figure out where the 4 goes and where the 3 goes, and it matters. I can't just put them, I can't put one in one place and the other in the other. It might not be right. So what was the rule? I take the largest factor and I put it where?
In the negative or minus?
Yes, with the sign of the middle term, which is negative. So the 4 goes there, 3 goes there. That is factoring in a nutshell at the easy level. And that will cover probably 90% of the problems they're going to give you or test you on. It really will. They don't give a whole lot of problems that look like this. They just don't. That's a hard factoring problem. The rules are all differently. We won't get into that today. But certainly we need to get into how to handle those because they are going to occasionally give you those. But this is what I would call level 2. It's not because this number is a 2, it's because it's not a 1. In other words, that might be a 4, it's still level 2.
Yeah.
Okay? And level 2 we'll work on at a different time, but you want to be able to master level 1 quadratics. Okay? And hopefully we've gone over enough today that you got a pretty good idea on how to handle level 1 quadratics.
Yeah.
Okay. Izzy, you want to call it a session for today?
Yeah.
Okay. And then your mother, Virginia, knows how to sign up for sessions. Done it.
Okay.
The only thing, if she's there, is she there right now?
She's downstairs, but I can.
No, you don't have to get her at all.
Okay.
She signed up for a 2-hour session because she thought it was going to be in person.
Yeah.
But if we're going to do the sessions online, which looks like it's going to be the case because I live quite a ways away from you, the only thing she needs to do is sign up for a half-hour online session or a 1-hour online session. And the session will begin at the time she signs up for, as opposed to in-person sessions where they actually begin a half an hour after the time she starts.
Okay.
To allow me to drive there. But when we're doing in-person sessions, if you want a session for an hour from 5 to 6, then choose a 1-hour online starting at 5.
Okay.
Okay?
Okay.
Izzy, I hope that's been a little helpful, and I will talk to you the next time. And have a good rest of your day.
Yeah, you too. Thank you.
You're welcome. Bye-bye.
Bye.